testing methods and tools. So yeah, a little introduction. You guys already know my name is Josh. I work at Bluehost. I was initially hired on to write a lot of the unit tests. What I specifically deal with is APIs, billing related software. So taking credit card numbers, processing, generating invoices, managing products. It's pretty fun. So I was out with lunch with Dave and Doran, and they were like, hey, we need someone to present. And then my supervisor Mike was like, well, Josh could give something about testing. And so
you got volunteered.
Yeah, voluntold or coerced, volunteered. I don't know, but it's something that I've been wanting to talk about, because people always come up to me like, hey, you should give a presentation on testing. And so anyways, here I am. So yeah, what is my presentation about? Testing, of course. If you haven't gotten that yet, well, hopefully. But more specifically, I mean, testing is a really broad subject. What this is kind of more covering is maybe more conceptual in theory, because we all have to work with different types of applications. I mean, not all of us work with API servers. Some of us might work with web development or deploying software on some system, or the list can go on and on and on. So first of all, I want to get in is perceptions of writing tests. Sometimes it feels like this monumental task. Often people are like, oh yeah, tests are good, but it's not something they're too fond of just wanting to dive into and get going. And so kind of what this presentation focuses on is providing you some tools on making it not as a monumental task, and hopefully you'll have some valuable insight here. If not, I apologize. At least I tried. So, so first question, before we even begin writing tests, there's some questions that we want to ask ourselves. One, what is our testing methodology? Probably a lot of us is more focused on unit testing, but there's functional tests, there's integration tests, there's load testing, performance, compatibility. The list kind of goes on and on, but it's a good question to ask, so that way we can kind of keep in scope, keep our eye on the ball, so testing doesn't become this huge monolithic thing where we're like, oh my gosh, we can't do this. So when you're actually writing a test, it's also important to ask what is expected when a certain given conditions are ran. Same thing again. It's kind of a nifty question to ask, because when you have that in perspective, then perhaps there are tools out there that can help you get what you want. And yeah, so just as I was saying, so which kind of leads into, are you using the best tool for the job? Are you trying to reinvent the wheel when there might be something already out there? So I'm going to probably go in a little bit to testing in a controlled environment. So kind of further my philosophy on when I write tests or run them, I like to be in a controlled environment here. Now I want to talk about semantics for a second. Sometimes you'll hear maybe other terms like clean, and I think that's sometimes misinterpreted, because people think clean is some pristine working environment, and the counter argument for clean is, well, I know my code runs in a clean environment, but I want to run in a live environment where there's all these variables, so that way I can find issues that crop up. I beg to differ. That's the whole point of I don't like using the term clean, essentially. So now maybe the term clean is more appropriate if you're talking about resetting your environment, because tests will go along and do something, and we want to ensure that tests thereafter are going to do what they need to do. So this actually goes into more of the why. And so the first thing is, why do we do this? It establishes confidence in the tests themselves are testing what they're intended to test. Hence, I'm not a fan of this whole philosophy of testing with all these variables in to find use cases that we would never think of, because if we include those in, how do we really know the tests themselves are behaving what they're supposed to do? And another reason why we test in a controlled environment is so we can better simulate desired conditions, so that way we can see if we're getting what we expected. And this is kind of no-brainer, but sometimes what we do in a test environment we don't want to do in a live environment, such as needing to test when a database doesn't exist. I hope we don't drop the database to test that. That would not be good. So, how do we do this? Well, we can use fixtures and to kind of set up an isolated environment. What we kind of do at Bluehost actually is we use fixtures to create a independent database and to spin up our own server instance. And also we have our own client that connects to that server instance. So that way our main server doesn't doesn't have these calls, and it's not writing to the real database. We're keeping things in our controlled, aka clean environment. And another method that we could also do is mocking, where you could go as far as, instead of like setting up your own database, you can use various different modules, like a test mock module, to override the handle and get like a mocked output when you like make a call or something like that. I'm going to probably get into mocking maybe a little bit later, but this presentation is more on the fixtures themselves. I believe mocking does have its place, and it's a very beneficial tool if used correctly. So, but yeah, so test class is a framework that I use for my fixtures. It's a really nifty framework, and we're going to probably spend a great deal of time with test class. So the benefits. So like I said, we get test fixtures, and it's like a XUnit style framework. If any of you are familiar with JUnit, so it's just this methodology to unit testing. Simplifies reusability, encourages refactoring. So we get kind of inheritance, so that way we're not constantly reduplicating code, which I've actually seen in some tests where I just facepalm because they have this one block of code for one script, and then in another script they have the same block but then more, and another script same block one more, and I'm just like, oh wow. So if they were using test class, we wouldn't have this repetition of code. We'd have a cleaner way to refactor all of that. And according to the documentation, it can reduce startup time, because what you're essentially doing is you're putting all of your tests in modules, and when you make your T scripts, it's compiling all those in, while if they were like independent scripts, they would need to keep being recompiled. So I don't stress too much on that because it's kind of like an asterisk there, can. And it's also compatible with test builder modules, so if you use test more, awesome. It'll work with things like test more, test D, anything like that. So there are some drawbacks, though. It's not a perfect framework. For one, it's overkill for simple testing. If all you want to do is a require OK for your test, make sure your module compiles. Okay, test class is probably not for you. It's another dependency to include in distribution. So if you wanted to release your module on CPAN and someone wants to use it, well, in order for them to use your application, they're going to have that additional dependency. And it is another framework to learn. And sometimes we're not always on board to learn a new framework, but yeah. This is kind of a personal thing that I do notice with test class. It wasn't really in its documentation, but the use of the subroutine attributes can be restricting, and I'm going to get more into that later. So to get started with test class, we just create our test class base module. So we have our use base.
It's in red.
Sorry,
is that test class?
Yeah, it's test class. Sorry, guys. But yeah, we pretty much just say use base test class, and it inherits all those fixtures, all those features. And typically, though, we still want to do like a use test more because test class doesn't provide those functions. And so when we get working with test class, we're going to have essentially test methods where most of our testing code goes. And test class defines test methods with the test subroutine attribute. And so when you run your test, it's going to go through the package, find all the methods with that attribute, and essentially run them. There's a certain order on how it runs, and we are also going to get to that later. Just kind of making you more aware of how we define our test methods. And so when we usually define a test method, though, we want to declare a plan, because declaring plans are good. And so we do this with the paren, and we put the number of tests we expect to be ran in this method. So in this case, we only have one OK, so we'd put 1. But if we had multiple OKs, like 2 or 3, then this number would be updated.
Does test class let you fiddle with the plan later on? Like if you get into it and then you realize, oh, I'm just in an environment, I can't even do this subset?
Yes. I can't remember what I think it's num tests. So inside your test method, in fact, I forgot to put that in these slides. Yeah, if you do set $self num tests, you can, I think it defaults to the current test method, and you can just pass in a number. So if you initially set no plan, you can still set it later on. Now the drawback to doing that is you won't have your plan stated at the very start of the suite, which can have some disastrous consequences. Where one scenario we stated a plan, but really the plan was 7, but there was really 14. No one ever updated the plan up there, and because there was another method that had no plan, it was actually dying just in time to complete the first 7. And so to the entire suite, to test class, it was like, oh yeah, we've made all of our methods here, when we really did not.
If so, we're using test mode, could we also use skip in that case inside the method if you don't have the environment? Could you have test 3 and then skip 3 if it?
Yeah, this is totally compatible with the test more skip.
Okay.
So Yeah, it's actually the same thing. You just use a skip block.
Okay.
And I think that's pretty much it about skipping. So it's actually the wonderful thing about it being compatible with Test Builder is if you're already familiar with Test More, you can use a lot of the Test More functions in Test Class. So, but yeah, when we can't declare a plan, like what James was saying, we can add a no plan here. And like I said, though, try to use that as a last resort. But you know, it's not always. We can't always. So that's. As an alternative no plan, though, we can use tests instead of tests, which defaults to no plan if it wasn't supplied. So running order now. So all of our test methods are ran in alphabetical order, so A, B, C, D, E, F, G. Underscores are started first. Now, every test method should be independent from one another. It's frowned upon in X and in J unit where you have your methods needing to depend on other methods. So whenever you're making a test method, make it independent. If you rely on one method to run before another method, you're sort of doing it wrong. Sorry.
But at the same time, wouldn't you want to bail sooner? So not dependency, but A needs to run before B, because if I have no environment, well then what's the point in hammering my other 50 tests?
Oh, yeah, there's actually, startup and, so what you're talking about is more of the startup, the fixtures?
It could be startup, but I'm just saying like this has to exist before this, or this needs to be tested before this, otherwise just stop, right? Like bail, right?
Yeah, and to a certain extent, like
require okay might be a good one. If this module doesn't compile, stop trying.
Yeah, so that would be probably more in a setup fixture or your startup fixtures. So I am kind of lying here when I say methods do need to be ran in independent from each other, because I am not really including test fixtures at this point. But yeah, so essentially what you are talking about is more of the fixture portion, which we get into. So, I mean, there's 4 different fixtures, types of fixtures. We have startup, set down, tear down, and shut down. So a startup fixture we declare similar to a test method, but instead we put a startup keyword in here. And it runs once at the start of the entire test suite. So if we want to do something very initial, basic, something for the entire suite, startup is what we want to do. Now if a fixture dies or if a test fails, all remaining tests are skipped. So something like we do at Bluehost is we create our database in our startup fixture. And we have a test for that. Well, if the database doesn't get created, if it dies or something like that, our entire tests are essentially skipped over. It doesn't.
You can't go on.
Yep, we can't. So that's kind of where we tackle our dependencies. There are setup fixtures which run every time before the execution of a test method. So if we have multiple test methods, like test method A, test method B, the setup fixtures will be ran twice, once before test method A, once before test method B. So this is nice. Well, let me talk about teardown real quick. So teardown is the same thing. It's run after the execution.
Of each method?
Yeah, of each test method. So using the setup and teardown, we can essentially reset our environment where perhaps in the setup we could create our tables or something like that, and then the teardowns we drop all of our tables, so that way we continuously have a clean environment for our tests to run in. And then the final fixture we have is shutdown, which is ran once at the end of the entire test suite. In this case, what we do is we actually completely remove our database. We stop the server instance and we drop the database, and we might clean up memcache. So yeah, just kind of cleaning up after yourself. And I mean, if it dies, I mean, there's really no other. It won't do a bailout. So if we have multiple T scripts, it will continue on to the next T script. So it's not like a mega bailout where it's like stop all remaining tests. And same goes with the setup the startup fixture. So now once again, we want to declare a plan for our fixture, and we just do fat arrow then our plan here. And so in this case, if we only had one, we do one. And similarly, though, we can declare a no plan for a fixture, or by either doing the no plan or the tests. So yeah, test fixtures can be a powerful tool to set up and clean up a controlled environment to run in. And how our application at Bluehost was we would override the config settings, create a testing database, instantiate a server instance, which would connect to our testing database based off of the configs we'd override. And then in our shutdown method, we would clean up after ourselves. And then also what we would do is our fixtures would reside in a parent class. So that way we're not continuously copying this set of code in all of our test scripts. We had a parent, we just do use base the parent class name and for all of our modules, and they would inherit that. So it's kind of same thing with test methods. Fixtures themselves, fixtures of the same type should be independent from one another. So if the order of application matters, so the order of operation. So in this case, before we needed to start a server instance, we need to create our database. Have that in a single fixture. Don't have multiple fixtures.
Probably because the order is not predictable or not easily.
Like I said, you could finagle it with doing alphabetical, where maybe you had like underscore and then A and then create database underscore and then B. But it's and that's usually the workaround, but it's really a frowned upon thing to do in the XUnit style framework.
And test class also looks at environment variables, so you can restrict which methods are run. So you could actually skip over those that you're expecting to run because they're run in alphabetical order.
So take it from us. Just put them in the same fixture, because I've tried that. I've tried separating them out, thinking this was great, but then I was like, oh, this is really not.
Great.
Yeah. So subroutine attributes, this whole concept of the tests, I mean, it's pretty cool. I mean, it's a nice way to declare what your methods are. However, it makes implementing your test class modules difficult as roles. Because essentially what I've been explaining so far is more of a role concept, where we have this behavior and we are really, it should not be a parent inheritance, but more as a role where you use something like auto roll or roll tiny or move roll. So why is that a problem with subroutine attributes? It seems like the attributes go off of the current package and the ISA inheritance tree, and I think a lot of times how role is implemented is usually via import. It doesn't work too well when you're using them as a role. So those subroutine attributes don't carry over into your subclass, they stay in that parent class. So when you run your tests, your startup method never gets executed because the attribute is over here. Now, test class does provide some methods for declaring what methods are your test methods. Forgot to put them in here. So, because there are some frameworks like test class sugar that can't take advantage of the attribute system.
So it's probably importer or exporter that's not playing heavy-handed enough to copy over the attributes to the symbol table where they've been exported to.
I assume.
Something like that.
Yeah. In fact. Yeah. This was my thing, right? Yeah. So.
Yeah.
If you do find a way to get those, please let me know. Because I do, a lot of my modules, I want them to treat them more as roles, but I'm stuck with doing a use base instead, which is kind of misleading. People get this idea, and it's actually caused a lot of confusion because they look at my code and they're like, wait, why are you treating this as a parent class? Is this supposed to be a role? This is totally a role here. They have this question mark on them, and I'm like, yeah, you're right, it is a role, but these attributes, they're not. So that's the attributes are kind of this double-edged sword for me. They're awesome, but at the same time, they're like frustrating. So. Now, if we want to run our tests, if we go back to our earlier example, we have our package foo, our test foo module here, and we define our test methods. We can have more test methods than this. We can have our setup methods. But yeah, so we have our test class base module. So essentially we would create a .t file, and we just say use our test class base module, in this case test foo, and then we call test class run tests, and essentially it'll go through and run our modules. Now you might ask, well, why we do this test class run tests? The nice thing about test class is you can have multiple test class-based modules in a single script, and it will run all of the modules that have been loaded in.
And is it in order of the use?
Actually, I believe it's in alphabetical order.
Okay, yeah.
I think it is alphabetical order. And run tests have some ways to filter out, like, I think what modules to run, or I might be thinking more of test class load, which is a nifty little tool for loading all of your test class-based modules where you're not always updating this file. Essentially, you can point to a directory, and you can even make filters on, say, oh, we'll only run these type of modules here. So it's pretty nifty. But yeah, I mean, I could probably sit here all day and talk about test class. It has a bunch more features. Mostly what I wanted to more go over is just the fixtures, how they can be ran, the application that we've used them for. But yeah, I recommend reading up the documentation. I'm really just scratching the surface here with test class. So a little bit about mocking.
Oh, not that.
Oh,
You were waiting for that.
So sometimes mocking gets misunderstood, hence it kind of has this bad rap. And I think whenever we mock, it's important that we ask, what we're testing for, because based off of that answer, mocking can be a totally appropriate thing to do. But then again, it can sometimes be the wrong thing to do. I really can't make a list here, say when to mock, when not to mock. It can get quite extensive because this whole what we're trying to test for question is pretty open-ended. But yeah, some pros to mocking is we can simulate our conditions that would be difficult to do in a real environment. So like I was saying earlier, when we want to simulate how our code runs when the database doesn't exist, I hope we our tests, don't drop the database to simulate that. But we could use mocking as a means to simulate that, where we could override the handle or override the configs just to give it some non-existing database. Now this example is this is a very limited example. There are a bunch of different techniques, what you could mock, what you could not mock. Once again, I don't really want to go through as a laundry list. Just kind of more of an open-ended thing to think about. Another thing is mocking can be very beneficial as it simulates our dependencies, so objects or services that are not present. There's like one use case I was reading where this developer had this code and sendmail doesn't run. He needed sendmail. It doesn't run on the same server as it usually does. It's on a separate server. It's ludicrous to require, to install sendmail on the server that the code's being ran on just so he can run the tests. And he actually found the solution was to mock it, because really what he was trying to test wasn't really all that important to sendmail in the first place.
One thing that I was thinking of is we have a service that we use at Bluehost. It's a third-party API, and they have a testing mode, but we still pay, even when we pay per transaction or per a certain number of transactions, even when we're using the testing mode, because they're just that awful. And so, if we're not really concerned about, we can simulate them giving us various responses, but we can mock it so that we're not actually talking to them.
Or
we
maybe
can have a separate test for that.
Yeah.
That we can do only when we're willing to pay the price, literally.
So we probably have a lot of tests where all we really care is to get a valid response. It is good to test to get an actual legitimate connection, like a legitimate response, make sure we're getting what we're actually expecting, but to do that over and over and over, if we just had one test that would suffice those requirements.
I had a few weeks ago a situation where I wasn't able to talk to the remote API because we hadn't had network access set up for them yet, authorization to, and so I mocked all of their responses based on their documentation. And then when we finally got our ACLs turned on to be able to talk to them, there was like one change that had to be made. All my tests passed, and everything just worked. So
it kind of allowed you to
kick the football a little bit further down the.
So twiddling your thumbs, being like, "Oh, I can't do anything." Yes, But yeah, marking can be argued, though, kind of like what Dave was saying here. It could make sometimes writing your tests faster because we're not jumping through all of these hoops to get our tests to run, like setting up sendmail. It's like, So, there are some cons to mocking, though. It can be misused where tests are not really testing what they're supposed to test. And what, like Doran was saying, there are times where we do want to make a request to this third-party service, because if we were solely relying on mocking, if they changed something on their end that would break our code, we would never really pick that up because we were mocking the whole time. It can take additional time to implement when an alternative solution may not. This might go into my third point. Mocking you can go overboard with mocking where you're pretty much rewriting an entire system. We've tried to steer away from that, but when Dora and I were actually first going in, writing tests, at first we're like, oh yeah, mocking, but then when we kind of got into it, like, oh, we're going to have to, because we work with FreeSide, we're like, we don't want to rewrite all of FreeSide, and And the solution was, well, why not we just create an independent database, override some configs, bam. So, but on a side note, it can be additional code to maintain. Kind of goes back to that same point. These are kind of the main arguments why people are against mocking. It has its place. Mocking's not this end-all, be-all solution. It's not the right tool for every job out there, but I feel like sometimes it can be the best tool under certain scenarios. But yeah, some modules that can help with mocking: sub override, test mock module, test mock object. The list gets kind of actually extensive, but these were a few that I've had some experience with, particularly sub override and mock module. I actually like mock module more than override. So I'm kind of getting near the end of my presentation here, but one thing I did want to touch up on a little bit was complex data structures, because we work with APIs and we'll get back these huge hashes, and that in themselves can be very monumental to test, especially when you start getting timestamps and you're like, oh god, like I don't want to. So a tool that we've been using is Testy, and in fact, in the test more documentation, when you use when you look at the isDeeply function, it will say you might actually want to check out Testy, because Testy can do a better job at complex data structures than isDeeply. Now, I'm not saying don't use isDeeply. isDeeply is fine if it's like a basic one-level hash, but when you start getting the multi-level hashes, you might want to start looking at Testy. It has a lot of convenience tools. So one of the tools for like timestamps, there's a regex function. So it's RE. You can essentially at least check to make sure you got a valid timestamp format. On a side note, though, that could be abused, because at first I was just doing, hey, is this 10 digits? Well, I actually found with one of our code, with MySQL, if you don't supply a date, an argument, it defaults to 0000.
10 zeros.
Yeah. So, it was coming back as passing, and so. We want to keep in mind, maybe use a little bit critical thinking when you're using some of these tools. My only complaint, though, my biggest complaint with TestDeep is sometimes the diagnostics can be ambiguous with some of their tools. So there's like a bag function, and if it doesn't match up, like what it does, it's for comparing an array against one another. And so if you're missing at a hash, it will just say missing a hash. It wouldn't say exactly what hash you're missing. So I kind of wish there was a little better diagnostics with Testy, but maybe I'm asking too much frosting on the cake here, because maybe you could get huge giant hashes and some people are like, no, I don't want that, and it might be TMI, too much information. But yeah, I'm pretty much at the end here. Are there any questions?